Thank you, Per, for the invitation, and thank you for coming to have the possibility to show you the system, to show you the components, and you have seen many things about this old mill that we have had the possibility to have the retrofit of the whole facade, and I will also show you some data that was measured there. Let me lose 2 words about Fixit, who we are, what we do. We are a producer of dry mortar in Switzerland. We have 5 own plants and also own quarries of gypsum. So we produce mainly gypsum products, but from paint also down to beton, down to concrete for tunnels, streets, and all the construction sites, all the constructed buildings that we do. So my part is to introduce also once again this CTI project. We heard it this morning from Mr. Knoblauch, the ambassador, who told us about the CTI Commission for Technique and Innovation that supports projects also like ours. Then some more properties and also the certifications, the tests that we did to prove these properties, some technical aspects about the product. Then from the pilot projects, also some experiences and further development. It does not mean that because we have some good pilot projects, we stop work with development at the product or at the possibilities to use the material. We go further. We want to find also different solutions because we have many different types of houses. And then finally, expertise about health, about environment, and these are points that are very important to us because Aerogel is a new material in construction, but as we heard, it is nearly, what is it now, 85 years or more that Samuel Kistler invented the Aerogel. So it's well known, but not really well known in construction. If we have a look at Canton Zürich, at the buildings that we have in Zürich, we see that more than 65% of all the buildings are more than 40 years old. And we have a huge amount, as we also have seen this morning in Norway, from square meters that are of historic buildings that are not insulated. We have an insulation rate in Switzerland that is about 1%. So if we continue like this, it'll take more than 100 years to insulate all our buildings. And I guess in that way, we don't achieve the climate targets. But we have this target. We want to reduce energy consumption. We see 73, 75 energy consumption in buildings was going lower because prices of energy were going higher. And when we look back, we see that at the end of the 19th century, energy consumption was also a little bit lower, just because the simple fact of masonry was thicker, and it was also possible to maintain heat into the stones, so it's kind of a heat memory also for the buildings. So what are advantages in insulating plaster? We heard about this morning from conventional insulating systems, but when you have a look at all the buildings, you see that we need other advantages as well, like a variability in thickness. We have masonry that doesn't go straight. We have rough surfaces. We don't want to create some cavity behind insulation. We want to have a compact fulfilled masonry that has no cavity, no big holes in it. And then, very important to the workers, to the ones that applicate the materials on site, it's easy to work with. We can, with a render, spray it with a conventional machine. We can create all the surface that is needed. We can model it very, very easy. So it is simple to handle and to work with. And very important, as we heard also from Dr. Niederberger and from Fixit Antiquaren this morning, we want to preserve the original characters of the buildings. We don't want to make them look all new. We want to have the old character, but a new quality of the building, so it can stay another decades. And last but not least, this low resistance against water damp diffusion, that is very, very important to these buildings, as we have heard several times today. So what about the system? There are, like we have seen before also, about 7 different components. First, that is not shown here because we don't have a masonry down there, is the rough cast. And it depends on which type of masonry you have. If it's a red brick, if it's a natural brick masonry, if you need a rough cast that is made of cement, or if it's made of hydraulic lime, also because sometimes you have limitations of the monument preservation. Then you go on with the desired thickness of the insulating render that you can see here, and it is fulfilled with it. You need on top of the insulating render, because it's not a really hard render. As you can imagine, achieving a thermal conductivity of 28 milliwatt requires also a very low density, and this goes also to the compression strength of the render. So it needs a surface stabilizer. That is a solution from silica also. That gives us an equalized surface, and it helps to apply also the embedding render that is also lime-based, to put in a reinforcement mesh that is made of glass fibers. That gives us the surface we need to continue with the finishing layers, to have a hard surface like we have on the buildings we know. And that lasts also long enough. So it is very important to use mineral components, that we don't disturb this low resistance against water damp diffusion, so we can keep all the system open to permeability. This includes also the paint, and as we have seen, a water repellent does not mean that this is really tight. It can also be open to water damp diffusion and nevertheless be water repellent. So how do we achieve thermal conductivity that is that low in a render? It's the aerogel granules that help us to do so. And its raw material is amorphous silica. It's known for thousands of years. Its amorphous silica was used also in Puzolan, in truss, and in several construction materials that go back until the Romans. But this amorphous silica has another way to be produced, to be optimized. It is liquid amorphous silica, like we know from construction sites as Kaliwasserglas, as a binder, and in a special way it is dried out under special conditions, so it keeps its pores and it keeps a nanoporous structure. And this is the very important thing. We talk about a nanoporous system and not a nanoscaled system. This is the big difference. If we look back to the raw material, we see granules that go from 0.5 to 4 millimeters. It's a really big granule. And Thomas is so kind to have brought some to me. You want to let it pass through? Perhaps you get it back. Have a look at it. So these small pores, they will do more than 90% of the volume of the aerogel. So we have the lowest thermal conductivity. Aerogel is also listed in the Guinness Book of Records. We have the lightest aggregate. We have seen these two this morning in another intervention. And it is hydrophobic. This is very important, that we don't have liquid water into the pores of the aerogel, so we keep the insulation. And nevertheless, it is permeable to water vapor. These are two topics of this material that make it so special. So you see here on this photograph also these 200 nanometers down on the left side, and the small dark points that show us the pores of the aerogel. So the air is included in very, very small pores from 20 to 80 nanometers, and 1 nanometer, as we know, means the part of a million of a millimeter. So it's the same proportion as 1 millimeter has to 1 kilometer. Just to get an idea of which size we are talking about. This sketch shows us how nanotechnology is classified, also after a ISO norm. And we have nanomaterials that include, on the left side, nanoparticles, which are nanoballs, nanofibers, nanoplates, that have a scale that go below 100 nanometers. But on the right side, as you've seen in the red sketch, we have the nanostructured materials that have a structure that is somehow in a nanometric system. And here the aerogel that is passing through the rose is a nanoporous system. So the smallest part of an aerogel particle, if you would take it out of the glass now and you would destroy it, you would get a part of a micrometer. That would be the smallest part that you get out of an aerogel particle. So you can't go down this size. And even if you destroy it that small, it still keeps its pores and it still keeps its characteristic as a good insulation aggregate. As you can see in this animation, we have a size of 200 nanometers. In conventional insulating materials, you have the red shown air molecules going free to each other to transport energy. In the aerogel, they are nearly by themselves, and so energy transport is much more difficult, and this is how we get this low thermal conductivity of 13 milliwatt per meter Kelvin on the aerogel granules. And this is a way to retrofit houses with a small layer of render. If we have houses with a small roof outstanding on the facade, we don't have enough place, and sometimes we don't want to change character even of conventional buildings like this. It's not listed, it's not protected, it's just a conventional house. And the owner wanted to do something special for it to keep its good shape, or put it back in a good shape, because masonry here was quite destroyed because it was covered with very tight Portland cement, with a very hard Portland cement render, and so it was really damaged. So the main characteristics, once again, of the Aerogel render of the Fixit 222 is the thermal conductivity that has a lambda small d, which means it's a declared lambda value that is proven by the European norm 12667, and in Switzerland we have also the SIA, which means Schweizerischer Ingenieur- und Architektenverein. I guess in Norwegian you would also understand Schweizerischer Ingenieur- und Architektenverein. They make the norms in Switzerland and have this Commission 279 that proves all the certification, all the tests of the insulating products, and so you get this lambda small d as a declared value. Then it is very easy to apply, as said, to applicate. You can put spray 6 to 8 centimeters in one time. We even sprayed 12 centimeters on several buildings on bigger surfaces, which means you start applying, you spray the whole facade down, and then you can start once again at once, and so you have a continuous process to get the thickness you need. But most of the houses have 3 to 7 centimeters of thickness on the facade that are retrofitted with this material. Like we have heard now, it's the value of the permeability, it's lower than 5. Well, the ones who make additions with the mu values, they know very well how low it is. And it's a product completely mineral and free from Portland cement, which is very important to historic buildings, not only the listed, but also the older buildings that had a lime mortar. And inside as well as outside. The combustibility, we have seen it in the video, is very strong, because A2, S1, D0 means it doesn't burn, it doesn't smoke, and it doesn't drop under the influence of fire. This is another object that we could make. It's the second pilot project that we had in Winterthur. It's a fabric worker house. They have whole quarters with houses similar to England also, where one house after the other is the same. And there we had the possibility to do one of the first facades with the system. And as you can see, the finishing layer is very rough. So we are free to create the surface we need. There are very many finishing layers back in time that were a very rough surface. We call it Tröbelputz, ein Kellenwurf. So this is very characteristical to the older facades. And you can see under the roof there the small red thing. That is the logger for the external, and the sond for the external temperature and relative humidity, and the cable that goes down the facade behind the insulating render and has another measurement behind the insulating render. And that was made on both sides of the house, and so we are able to compare the different orientations of the facade, the different influences, because on the north side we have less sun, we have also some less rain, but it's colder, we have more wind, and on the western side, for example, it's more wet. So now another nice picture from Sissach. It was quite courageous from us and also from the owner of the building, because he had a facade of 550 square meters and he wanted to be the first to use this material. He called me months for months to ask how far we are with the development, And once he said, I don't want to bugging you, but I really want to be the first to use this system on my house. We have seen why, because of his mini-watt, mini-fossil and mini-car concept. And finally, he achieved it. So we had U-value at the beginning of about 2, because the masonry was very inhomogeneous. There are bricks from rivers. There are some mortars in there that are very, very soft. It has lots of sand in it, and so this is a very bad U-value also for a masonry. But it's typical for this type of houses. And you can see with the first few centimeters, we come down with the U-value very, very strong. And he has made the addition over all the surfaces that we could apply 3 to 7 centimeters. And we have an average U-value of 0.44. And that gave him, after all these steps of insulating, we have seen the concept by insulating the roof, by changing the windows, by insulating ceilings, by changing the heating concept. And the last step he did was insulation of the facade, and then he could reduce his energy consumption another 60% or more. So this is, we have seen that the energy loss on a house is about 40% on the facade. And on this house, we see that we don't have too many windows. We have here on the east and northern side also big surfaces of plaster, of render. And this is a reason why he could reduce energy consumption so much. 5 minutes. So I have to be quick now.
Well, it's not.
Give me 7, please.
It's okay, because we have coffee now. So and questions.
Okay. I don't have coffee, so I can speak a little bit longer. And in comparison to conventional insulating mortars, we see that the thicknesses are up to 3 times smaller in how low we want to come with the U-value. If you want to have a supported retrofitting in Switzerland, for example, you have to go down to 0.25. But we see how low the curve becomes, the more insulation we have on the house. So it's a question about, do we need to insulate all these old houses so strong, or does it fit also for these 1, 2, 3% of historic buildings to insulate them a little bit smaller, but have a really good effect? We have heard about this timber, these wooden houses filled up with stones. The older ones also in Switzerland were filled up also with lehm, with clay and with straw, because they hadn't enough stones, and stones were also expensive. And this was the way to build houses. What you don't see here is the Ziegelrabbits. It's a mesh of draht, of metal, and of some small red bricks. And this helps us to keep the render on a facade like this. And finally, we get a nice historic object with an energetic, better facade. Another example from Zurich with brickstone masonry. We had 4 centimeters of insulating layer with Aerogel, and we could come down with the U-value another 60% and reduce energy consumption on nearly 40%. A bigger one in the city of Zurich, in the heart of Zurich. It's a facade about 1,500 square meters. it was a listed object, it is a listed object, and they couldn't put on a big layer of insulation, but they wanted to do something. They had a facade that was also made with a very hard Portland cement render, and so they decided to put that away and to recreate it with the hydraulic lime insulating aerogel containing mortar. What have we done else? We had this test report about the declared thermal conductivity, and we tested also the aerogel itself and the render on volatile organic components, because we heard it's a modified amorphous silica, so there is a hydrophobic agent also in the aerogel, and we wanted to test it if we have some emissions on that, if we had an effect. And if we had a bad effect, it wouldn't be free from VOC, and we wouldn't pass also the combustibility test, because if you have too much emissions, you don't get classified A2 with the construction material. And further on, we did also a life cycle assessment according to the ISO 40040, and in successive to that, the environmental product declaration, which is going to be online also in a few days, according to the EN 15804. What I can say about that is the big question is always the gray energy. When is the energy payback done? How much will it take? And if you take an example of 5 centimeters of aerogel high performance render, you have the energy payback in less than 3 years. It's 2.8, 2.9 years, depending on the type of house, naturally. But you can say that with 5 centimeters, you don't need 2 years to get the energy payback. And I think for new insulating materials, it's quite strong. And we did also measurements of dust and powder whilst production, whilst working with the material, because we wanted to know for our people in the plant, have they to take other measurements as they do now, or can they, is there some danger also? And we have seen that we don't have any dust that is dangerous. We have the same dust with this material that you have with other lime or cement mortars that are common in the building industry. So regarding the safety requirements, as you have to look after with every construction material, you are safe. And to prove that, we did a human toxicological assessment by a specialist in nanotechnology also, and he's also a biology scientist and a professor for lung diseases. So this man knows what he is talking about. And he tested the material, he got all the information, the recipe, etc., to prove that the product is not damaging our health. And the main two questions were, does the aerogel granulate contain nanoparticles? And as I explained you before, there are no particles, it's nanostructured. And if there were any health risk. And requiring the Swiss law of chemicals and industry products, you only have to follow the normal safety guidelines with the normal construction products.
So we have 2 minutes now.
Sorry?
You only have 2 minutes left now, otherwise there's no coffee.
That works out fine. Sorry. So I hope to tell everything, that there are a few questions afterwards. But I think for Norway, we want to know what about the facades with the more moved surfaces, I say. And we have a project running in Vienna with these historic facades, with the so-called Gründerzeithäuser, because they have facades that are very moving, that have these cornices, that have these stuccatures, and so it is running now. As you can see here on the left side we have the Aerogel render, and on the right side it is the common like it was before. And as you can see here on the left side, the new part with the Aerogel render doesn't show another picture like the existing building. And this project is also running now for several years. We control that, we keep that in an eye on it, and so we know how to continue also with these houses in the bigger cities. And last but not least, let me tell you that EMPA and Fixit have also won the Environment Prize in the category of innovation. And you find references naturally on our homepage, and also lots of information on the separate homepage of Aerogel, which is also in English there. And I think there are many informations there. So let me say takk for oppmerksomheten, and if there are questions.
Jeg har et lite forslag. Altså, de som tørste for å gjøre det, og de som vil spørre for å gjøre det, så får vi prøve å gjøre det samtidig. Da. Men klokken 2 så skal vi fortsette videre med programmet. Ja? Can you comment a bit more on the longevity, the expected longevity and the process of renewal of this system?
I don't understand too much the aging.
Yeah.
We did some aging tests at the EMPA, also with the climate chamber, and there we have seen that it will last for decades. But I will tell also my daughter to keep an eye on the buildings when I'm not there anymore. So this is the goal.
But if there is a need to renew the whole thing, what do you foresee as a process of that?
Sorry?
For how many years will it last?
Well, no, that's just part. I mean, you said last many years.
Ah, yes, I would do it. I would redo it.
The whole thing, you would start from scratch. That's the essence.
It's a difficult question. Sorry.
Ståle, hva det du spør om?
We discuss it afterwards on the coffee.
Well,
other questions?
Vi tror at dette her 50-100 år.
There is a certain amount of energy that is used to produce aerogel, and this is why we make the life cycle assessment to verify exactly also the energy payback, to know how much energy must be saved with the render to be back on zero. And this is below 3 years. Yeah. And it's getting better. Yes.
Yeah, Harald.
About the maintenance. Is it maintained as a normal lime rendering?
Yes, sure. Yeah. Because we use the same components as we have known for many centuries. There is natural hydraulic lime, there is hydrated lime, and also a small amount of white cement for the first hardening. So if you